$2 trillion US power grid sends electrons along a continent-wide network of conductors, transformers, cables, and wires, making sure there are always enough generators spooled up to send electricity to every single power outlet in the grid is built to meet the brief periods of peak demand, like the hot summer days when air conditioning use can double average electricity consumption. But what if you could just hold on to electricity for a bit and save it for later? The US has been using a crude form of energy storage called pumped hydroelectric power storage for decades. The country is now experiencing a gargantuan surge in energy storage capacity, this time from lithium-ion batteries. The power sector remains the second largest source of greenhouse gas emissions in the US. There will be no way to add enough intermittent clean energy to sufficiently decarbonize the grid without cheap and plentiful storage. If we can get it right, true grid-scale battery storage won't just be an enabler of clean energy, but a way to upgrade the power system for a new era. Zahir Ansik is now the president of Fluence, a joint venture between AES and Siemens. Fluence has deployed 38 gigawatt-hours of storage to date around the world. Last year, the largest storage facility, the most common battery storage technology, lithium-ion cells, saw huge price drops and energy density increases. That's partly because the cells on the power grid aren't that different from those in mobile devices and electric vehicles. China now produces 80% of the world's lithium-ion batteries. The combination of solar plus storage accounted for 84% of new US power added in 2024. Grid batteries don't have to be small enough to be mobile. They can take advantage of cheaper, less dense batteries. There's even talk of giving old EV batteries a second life on the power grid. The Federal Energy Regulatory Commission's Order 841 removed some of the barriers for energy storage systems to plug into wholesale markets. The regulation was issued in 2018. It cleared a major legal challenge in 2020, paving the way for more frequency response as an important ingredient in grid stability, reliability, and resilience. It helps ensure a steady flow of megawatts during blackouts and extreme weather. Grid batteries can also step in as reserve power when a generator goes offline. Batteries have already proven useful for overstressed power networks. As temperatures reached triple digits in Texas last year, batteries provided a record amount of power. Between 2020 and 2024, Texas saw a 4,100% increase in utility. Most thermal power plants prefer to run a steady pace. Ramping up and down to match demand takes time and costs money. Batteries soak up some of the variability, reducing greenhouse gas emissions. Standalone batteries allow the grid to adapt faster to changing energy needs. On balance, this leads to a more stable, efficient, cheaper, and cleaner power grid. Most grid batteries are designed to store and dispatch electricity over the course of 2 to 8 hours. The grid also needs ways to stash power for days, weeks, and even months since power demand shifts throughout the year. Like most grid, there are dozens of battery factories in the US now, though most are aimed at electric vehicles. There are 10 US factories slated to start up this year, which would raise the total EV battery manufacturing capacity to 421.5 gigawatt. The Trump administration is also working to undo incentives around clean energy, particularly the 2022 Inflation Reduction Act. Still, utility-scale energy storage is a tiny slice of the sprawling US power grid. The Edwards and Sanborn project has a capacity of 3.3 gigawatt-hours and 110,000 homes. You could easily see storage becoming 20 or 30% of the